Okay. I told in the previous class this function, like how the function is depending on more than one variable. That's why like we have taken one example, volume of the cylinder, that can be written in term of 1/3 pi r square h. So here r and h, these are the radius and height of the cylinder, and the volume is depending on these two parameters. Then we can say this volume is the function of two variables r and h. Okay. And I also told one more example we can take here. If we are taking in real life situation as crop, it is depending on lot many factors, as we can say rain, sunshine, fertilizers, soil, and other factors also. So we can say like crop is not the function of only one thing, it is a function of several variables. So to study function of several variable is very, very important, because whenever we want to deal any real life situation or any real life problems, then we should understand like function, if like how the a function depending on lot many other factors. So that we have discussed in the previous class. Now after that we have discussed about domain and range of a function. Like suppose there's a domain that is containing n components like x1, x2, x3 up to xn, and it is, and the range of this function is what? W. That means what? If we are writing W equal to f of x1, x2, x3 up to xn. Okay, so this function f is the function of n variable like x1, x2 up to xn, and this function could be any kind of suppose like it is the sum of n variables like x1 plus x2 plus x3 up to xn. Then whatever the output we are getting. Yes, good afternoon. So this W is what? That is the output that we are getting, and this W is belonging to R. Okay, and so what we are doing here, we are just explaining f is a function that is giving a real value W, okay, by taking input as x1, x2 up to xn. Okay, so here f is a function that is related to D and R, where D is what? That is the domain, it is containing n elements, and R that is containing one output, and this W is belonging to R. R is what? That is the set of real numbers. Understand? So if you're having n inputs, okay, n inputs, then we are calling it as n tuples, and we are saying that these n values x1, x2 up to xn together, these are belonging to Rn. Rn is what? That means each component of this element is belonging to R. So x1 is from R, x2 is from R, xn is from R. So it is combinedly belonging to the set Rn. So, or if you're taking n equal to 2, that means there are two components. It is also called as ordered pair. Okay, ordered pair. So it is belonging to what? R square. That means we can say first argument, it is also belonging to R, and the second argument, that is also belonging to R. So R cross R, that means each element of this number is belonging to R. So we can say xy is belonging to R square. So R cube, that means there should be three argument inside that particular element. So we can say xy is what? Let us suppose we are calling it as x. So this x is having two components and belonging to R square. If I'm saying here, like maybe y is belonging to R cube. So what does it mean by this element y? So this y is having three components like y1, y2, and y3. These all three components, y1, y2, and y3, are belonging to R, or they are real numbers. Understand? So y is, if I'm writing y is belonging to R cube, that means it is having three components. If I'm saying y is belonging to R5, that means 5 components. So that I have discussed in the previous class. One more thing I have discussed about the domain and range of the function. If some function is given to you, fxy equal to under y minus x square, then what would be the domain and range of the function? So this example we have discussed. Fxy equal to in order to find out domain, we will check for what value of x and y it is defined. So this function, if we are taking negative value, if y minus x square is coming out to be negative, then function is not giving any real output. So fxy is real whenever the term inside the denominator is greater than equal to 0. So domain is what? That is y is greater than equal to x square. Understand? So this is the thing we have discussed. So domain is what? X set of x and y, that those are satisfying this condition, y is greater than equal to x square. And range is what? That is what output we are getting. So y minus x square. So if you see from here, that will be what? From 0 to infinity. For y equal to x square, we are getting 0, and what y is greater than x square, we are getting different values. So this is the case. So we have discussed several examples. I will share examples with you. So after that, we discussed limits. So I'm just starting from today's class. Like I have given little bit introduction about the limit of the function of several variables. Suppose so first recall what is the definition of limit in one variable or in one dimension. Suppose y equal to some function fx and it is in one dimension. Okay, if we are writing limit x is tending to a, then f of x is coming out to be L. So what does it mean? It means like x is moving toward the point A. Suppose this is the point A and x is from left hand side as well as from right hand side. It is approaching toward A. Then we are saying the function fx is moving toward the point L. So I should write a smaller. So x is tending to A, then we are saying fx is moving toward the point L. Okay, so we are saying here fx is close to L whenever x is very, very close to A. So this is the definition of limit in one dimension. On the same basis, we can define limit in when the function is of two variable or more than two variable. So I'm writing for function of two variable. If the function f of xy, the function f of xy is arbitrary close to a fixed real number, maybe suppose L for all x and y sufficiently close to a point x naught, y naught, then we say that f approaches to the limit L as x and y approaches to the point x naught, y naught, to the point x naught, y naught, or in mathematic form we can write it as f of x comma y equal to L. Okay, I'm writing capital and small L, so just please do. Okay, for two dimension I'm writing capital L. So x comma y is moving toward the point x naught, y naught. So this is the definition of limit of the function of two variable. Okay, so fxy is arbitrarily close to a fixed real number, suppose L, and xy sufficiently close to a point x naught, y naught, then we'll say that L is the limit of the function fxy. Let us understand it graphically. Yes. Suppose this is the point, maybe x naught, y naught. Okay, this is the point x naught and y naught. And we are saying xy is what? That is any general point. But here it is in 2-dimension. In that case, xy is what? It could be anywhere inside this disk about the point x naught, y naught. Okay. So this xy is what? It is approaching toward the point x naught, y naught. Okay. So xy could approach to x naught, y naught by any of the path, like that. Okay. So xy and xy are approaching toward the point x naught, y naught. Then fxy is what? The limit of fxy is what? That is only one real number. So we can understand in terms of x in 1-dimension only, because fxy is giving output as L. So this is your L. So fxy is approaching toward the point L. Okay. Fxy is approaching toward the point L. Then we'll say L is the limit of the function fxy as xy is approaching toward the point x naught, y naught. So this is the definition of the limit of the function of two variables. Okay. So if you have any doubt up to here, then ask. Otherwise, I'm moving toward.
Ma'am, could you repeat that? Like you said, when xy approaches to x naught, y naught, then fxy will approach a real number.
L. Real
And
number.
then L will become the limit of xy.
Yes. Then L is the limit of the function fxy when xy is approaching toward the point x naught, y naught.
मैम मैम ये डिस्क वाला दोबारा बता दो.
डिस्क वाला एक्चुअली इससे पहले एक और चीज बताते हैं. लाइक सपोज यू आर इन 1-dimension. ठीक है. इन 1-dimension, लाइक इसी एग्जांपल से एक्सप्लेन करते हैं. इन 1-dimension, व्हाट इज द डेफिनेशन ऑफ द लिमिट? y equal to fx, we'll say limit x is tending to a, fx equal to L. So what does it mean? As we are approaching toward the point A, okay, x is moving toward the point A, then we are getting fx equal to L. Okay, na? So that means what? L is the limit of the function when x is moving toward the point A. How in 1-dimension, how this x is moving toward the point A? It will move from left hand side as well as from right hand side. Okay. In 1-dimension, because in 1-dimension you are having only two direction about the point A, left hand side as well as right hand side. But whenever we are dealing in 2-dimension, okay, in 2-dimension, so in 2-dimension, how you will move toward this point? There is not only one direction. There are infinitely many directions. So this is point x naught, y naught. So in the neighborhood of this point, how many xy occur? It could be like everywhere. So we can form a disk about this point x naught, y naught. So xy can approach to this point from any of the path. Understand? So in 1-dimension, we are taking only, it is only it is in term of interval. But in 2-dimension, it is in term of disk, because about the point x naught, y naught, we can form a neighborhood, and that neighborhood contain all the point that is lying inside a small circle, we can say. Understand?
Yes, ma'am.
Is it clear or not?
Yes, ma'am.
So let us understand limit in 2-dimension by the different paths. Like in 1-dimension, there are only two paths, and if left hand limit is coming out to be right hand limit. In 1-dimension, if we are getting left hand limit equal to right hand limit, that means a plus and a minus. It is when we say it is limit exists. But here in the case of 2-dimension, there is infinitely many paths. There is not only two paths. In 1-dimension, there are only two paths, left hand as well as right hand. But in 2-dimension, there is not only two paths, there are infinitely many paths. You can approach to this point by any of the way, like that. So in order to check whether the limit exists or not, then we have to check all the paths, and if the limit is coming out to same by all the paths, then we'll say limit exists. But it is not easy to check all the paths. Okay, so I'm writing here. So in one dimension, there exists in one dimension, there exist only two paths, right hand path and left hand path. Left hand path. But it is not the case with the function more than one variable. So in two dimension path, like in two variable or more than two variable, there exist infinitely many paths, path to approach the point x naught, y naught. To approach the point x naught, y naught. Okay. So these point could be like, it may be a straight line. Suppose I'm writing here again, like this point. So it could be a straight line, it could be some parabola, it could be some other function, other curve, or it could be anything. So there are infinitely many paths by which we can approach to the point x naught, y naught. Understand? So this is the difference between the limit for one dimension and two dimension, or maybe more than two dimensions. So I'm writing if y any two paths. Suppose we are taking any two paths. Maybe we are taking limit of fxy as x and y is tending to maybe x naught, y naught. Okay, by one path it is coming out to be suppose 1, and by another path we are moving toward the point f of xy equal to x and y is moving toward the point x naught, y naught, and we are taking path y equal to maybe mx or maybe 2x. It is coming out to be 5. Then we say limit does not exist. So we'll say limit does not exist. Does not exist because you're not getting same value of the limit by two different paths. अगर आपका यहाँ पे left hand limit and right hand limit same नहीं आता है तो आप कहते हैं ना कि limit does not exist. Same thing is here. You are getting limit by two different paths, different limit values. Then we'll say limit does not exist. So, like, what is the best way? Like, you can ask here why we are choosing only y equal to x and y equal to 2x. You can choose any of the paths. Yes.
Yes, ma'am. Yes, ma'am. No, ma'am. I was
Okay.
saying,
So you can choose any of the paths by which we can approach toward the point x naught, y naught. Let us take an example. Like before that, let us find out like how to proceed to compute the limit of a function by two-part test. Actually, here we are using two paths like y equal to x and y equal to 2x. So we call it as two-part test. By two approach, we are getting different limit. Then we'll say limit does not exist. Okay. So that's why this method is called two-part test. So what we will do, we'll try to find out any two paths by which we are getting two different limits. Then we'll say limit does not exist. So how to proceed? For that, what we will do, we will find, suppose you have to compute limit of a function as x and y is tending to 0, 0. Suppose we are finding limit of a function where x and y is moving toward the point 0, 0. So what is the procedure? We will take a general path. Take a general path. take a general path. What could be a general path? Find any straight line that is passing through 0, 0. So that could be y equal to mx raised to power p we can take. If p equal to 1, then it is a straight line. Okay, then y is a straight line. If p is greater than 1, it is a curve. Okay, then it is a curve. So I'm saying like what is your aim? To move toward the point 0, 0 by any of the path. So we'll take y equal to mxp. So x, when y is tending to 0, x is tending to 0. So this two-dimension problem can be written in term of compute here f of x. Now put y equal to mxp. Okay, and then limit x is tending to 0. X is tending to 0. Understand? Compute limit x is tending to 0. F is the function of x and y. Y is what? That mxp. If this value, if limit depends on m, if limit depends on m, then we can say limit does not exist. Limit does not exist. Why? Because you are getting limit in term of m, and m is what? That is not fixed. M is varying. That means m equal to 1, 2, 3. That means there is a different slope. So you are getting different value. As the value of m change, you are getting different limit. So you will say limit does not exist. Okay, but if it does not depend on m, so just note down this point. If limit does not depend on m, if limit does not depend on m,
Excuse me, ma'am.
yes, पूछिए.
बट यहाँ पे जो हमने लिमिट चेक करनी है वो एक्सटेंडिंग टू 0 के लिए चेक करनी है. तो मैम
हाँ.
एक्सटेंडिंग टू 0 के लिए तो फिर वो m की कोई भी वैल्यू हो 0,0 ही आएगा.
That depend on the function, na? That depend on the function. That I'm going to do one example, then we will discuss. Huh?
And ma'am, one more doubt I have, मैम दैट जनरली जैसे हम +1 या +2 में क्वेश्चंस करते थे तो हमें जिस फंक्शन की लिमिट देखनी होती थी हमें वो फंक्शन पता होता था. यहाँ पे हम डायरेक्टली f ऑफ x, y कह रहे हैं, उसके फंक्शन की जरूरत नहीं है हमें कि वो f ऑफ x, y क्या फंक्शन है.
Like that I'm going to just say, I'm just writing what will happen. This is xy is any function, na? It could be any kind of function. Like if I'm taking one example here, f of xy equal to, suppose you are having function f of xy equal to 4xy square upon x square plus y square. And here we are taking x is tending to 0 and y is tending to 0. So this is the function of two variable, na? 4xy square upon x square plus y square. And limit you have to check at xy is tending to 0. Then what you will do?
Y equals to mx.
So what you will do, you will just take y equal to mx. This is one path. So m is equal to what? M is slope. So that means any of the line, this is your 0, 0 point. Okay. So any line that is passing through 0, 0, you can take. Not only equation, you can take mxp. Any curve that is passing through 0, 0. Okay. So this is the thing that I'm saying. Any curve that is passing through 0, 0. So I'm taking this particular example. One more thing I just want to write here, xy. This is the example I want to take. And I'm writing here limit x comma y is tending to 0, 0. And fxy is what? That is your function here. 4xy upon x square plus y square. Okay. Now I'm writing here y equal to mxp. Mxp, why we are putting? Because this line y equal to mxp, p equal to 1, suppose. This line y equal to mx, it is passing through the origin. So we can convert this into one dimension problem, like limit x is tending to 0 and we are plugging this y as mx here. So what is happening here? X equal to m square, x square, value is coming out to be what? here limit x is tending to 0, 4m x square upon x square plus m square x square. What is coming out to be here? X square is getting cancelled after taking this common. It is coming out to be 4m upon 1 plus m square. So limit is what? Limit is coming out to be 4m upon 1 plus m square. So if m equal to 1, suppose you are taking m equal to 1. In that case, the value of the limit is what? Then the limit value is coming out to be 4 upon 1 plus 1. It is 2. M equal to 2. You are getting different value as 8 upon 1 plus m equal to 2, 4. 8 upon 5. So you are getting different values. So you can say here, when you are taking y equal to x, then limit is coming out to be 2, and you are taking y equal to 2x, you are getting limit value as 8 upon 5. So you are getting two different limits, then we will say limit does not exist. ऐसे ही आप वन डायमेंशन में भी करते थे, वहां पे आप लेफ्ट हैंड लिमिट और राइट हैंड लिमिट कंप्यूट करते थे, बट whenever you are dealing with two dimension, in that case, like there is not a single interval, you are moving to the point 0 0 by different paths. Okay, so that's why. So let us come to the point. So just read this point 1. Point 1 is what? If the limit depends on m, then we can say limit does not exist. Okay, but if limit does not depend on m, then what you will say? If it does not depend on m, then what you will say?
And if it does not depend on m, then that means it does exist.
It is not the case. That's what I'm saying. So there is no assurance.
मैम ऐसे तो m बार ही नहीं होएगा.
वही problem है इसके साथ. I'm going to explain. Then still you can say limit will not. So there is no assurance that limit will exist. It may or may not exist. Okay. So what is the reason? Because we have taken a particular path, that is mx raised to power p. Mx raised to power p. So we have taken some particular part. As I told you here, in this particular example, I am taking y equal to mx. Y equal to, and m we have taken two different value, and we are saying for this case, when we are taking y equal to x and y equal to 2x, and suppose you are getting result that is not depending on m. But maybe there are some path like y equal to x square or y equal to x cube or any other path, y equal to some sine x function that is moving toward the 0. Okay, so there could be any other path by which maybe it is not depending on m, but limit may not exist. So how to get surety that the limit will exist? How to get surety? So there is a technique that is called epsilon delta. There is a technique. So there is a epsilon delta definition. Okay. But that is not your syllabus, but I just want to give an example so that it should be clear when limit will exist. Okay, so there is an epsilon delta definition. It always works. But it is not very simple. It is very difficult. It depends on the problem. Okay. So what is that? This is given. Epsilon greater than 0. Find another number.
Ma'am,
that-
what you have written after there?
It always works. This technique, epsilon delta technique, that always works. Okay. You're asking this or what?
Yes, ma'am, I was asking this only.
So this technique always works, but this is little bit complex. So given epsilon greater than 0, find another delta. So what is that technique that I'm going to discuss here? So given epsilon greater than 0, find another number delta such that, so what is the relationship between epsilon and delta that I'm going to discuss? Such that f of xy minus L is less than epsilon for all xy minus x naught y naught is less than delta.
Ma'am, you
Means
have
what?
taken mod here.
Pardon? Yeah,
Ma'am,
mod.
have you taken mod here?
Yes, mod. Okay. We buy mod because we want only the positive value. So what is this technique? In this technique, for given epsilon greater than 0, epsilon is what? That is a small number. So just understand it in this way. This is the point x0, y0. And what we are doing, we are just finding a small neighborhood about the point x0, y0. This is your x0 and this is your y0. This point is x0, y0. And about this, you are finding a small disk of radius delta. If it is 2 dimension, then you can say it is a circle. Okay, its radius is what? So what does this mean? It means here x minus x0 square plus y minus y0 square. इसका मतलब क्या है? Mod of xy minus x0 y0. इसका मतलब है it is a distance between xy and x0 y0. So x0 y0 is what? That is the center about which we are finding a small circle of radius delta, or a radius whose that is less than delta. We can say it is very, very small. Okay, and it is greater than 0 and less than delta, we are saying, such that fxy, the distance between L, it is in one dimension, it is L, and fxy. Fxy is what? It is somewhere here or here. It could be anywhere, because fxy is what? That is that is on real line, and L is what? L is the limit of the function fxy. So this is your function fxy. The difference between fxy and L is small for all xy is less than xy minus x0 y0 is less than delta. इसका मतलब क्या है? If we are for given epsilon greater than 0, given epsilon greater than 0 का मतलब क्या है कि difference between the function fxy और L जो है इनके बीच का difference बहुत small है, then we have to find out such delta for which we are able to for which the distance between xy and x0 y0 is less than delta. तो हमको delta की value in term of epsilon we have to compute. If we are able to find out, then we can say limit exists. So I'm saying it is a theoretical part, so we will not discuss it in detail, and that is not in your syllabus how to compute this epsilon and delta. But you were asking like when we'll say limit will exist. Limit will exist whenever we are able to find delta for the given epsilon. Then we'll say limit exists. Okay. So I'm leaving it here because it is not in your syllabus. So come to the yes.
मैम ये चैप्टर कौन सा है?
Function of several variable. 12.1 if you are talking about 9th edition. ठीक है ना? Partial derivatives के नाम से, but the first topic is function of several variables. 12.1 exercise. ठीक है ना? So we will not discuss in detail. Let's go to the again this example. Those are simple based on simple limit. Okay. So now let us do one more example here. Now find limit as xy is tending to 0, 0, x square minus y square upon x minus y. Now find the limit of the function. How to do?
Put y equals to mx.
मैम पहले
equal to
सिंपलीफाई
m.
कर लेते हैं, फिर y is equal to mx डाल देते हैं.
So whenever you are getting, if we see here x and y is tending to 0, 0.
First, we can simplify
0 by
this.
0. It is 0 by 0 form. You know? If you compare it with the one dimension case, in one dimension case, whenever you are getting 0 by 0 form, then you apply L-Hospital rule. But here it is not allowed. So in 2 dimension, we are not using L-Hospital rule. So what we'll do,
We can turn it into x plus y, x minus y in the numerator.
We can simplify it. You know? X minus y into x plus y upon x minus y. Okay, so x minus y is getting cancelled. So y is tending to 0, 0. So it is coming out to be x plus y and x plus y. Okay. X comma y is tending to 0, 0.
I think
Yes.
the limit doesn't exist there.
It is coming out to be 0.
मैम
It is
वन
coming
डायमेंशन
out.
में करके नहीं लगा सकते हॉस्पिटल?
अगर वन डायमेंशन में करके लगाएंगे, like you are taking one two part test, y equal to mx. Here you are taking. then in that case also you are getting limit 0, 0, na? You are taking y equal to mx. In that case, limit will be what? It will be x square minus m square x square upon x minus mx. In that case, what you're getting, it is coming out to x into 1 minus m square upon 1 minus m. It is not coming out to be in term of m. It is coming out to be 0 if you're taking limit x is tending to 0. So in that case, it is again a undetermined case. जैसे कि आपका one dimension में होता था कि आपका अगर 0 by 0 form आ रहा है या फिर 0, like here you cannot conclude anything because it is coming out to be 0. So that's why what we have done, we have tried to simplify it.
But वहाँ से भी तो 0 ही आ रहा है.
हाँ, 0 आ रहा है, that is okay. I told you here one thing. If limit does not depend on m, then still there is no assurance that limit will exist. So हम क्या करते हैं कि जब आपका m पे depend नहीं कर रहा था, you are getting 0. So it is not certain that this is the limit. So what we will do, we will try to simplify it first and then we will compute the value. ठीक है ना? तो इससे क्या हो रहा है कि m पे डिपेंड नहीं कर रहा है. पिछले वाले केस में क्या था कि m पे आपका डिपेंड कर रहा है. So we are saying limit is coming out to be 0, but here we are not saying limit is 0. Understand? So what you have to do
in this the x will also get cut now, so we'll get only constant value of m.
so x, here you are getting x plus y and now you are putting value 0 plus 0. It is coming out to be 0. Okay, but here I told you whenever we are applying two-part test, so there will exist two cases. One is what the limit will depend on m and limit will not depend on m. When limit will depend on, then it is sure the limit does not exist. When it is not depend on m, so we can say like limit may or may not exist. Okay, so in this case, if you are doing it by this way, so we can say limit may or may not exist. Why it is so? Because two-part test is only for non-existence of the limit. Limit may or may not exist. Why? Because, just note down here, two-path test is only for non-existence of the limit. Non-existence of the limit. आप कुछ भी बोल नहीं सकते. अगर वो आपके पास two values किसी भी पास से आप चले जाइए, you are getting same limit. You are getting like 0, 0. But still you cannot say limit will exist. So two-part test only for non-existence of the limit. But if you are getting some value by simplifying it, like in this case, x minus y is getting cancelled, then you are getting x plus y and we are getting a value of the limit. So now we are saying it is the limit, but in this case we cannot say because two-part test is only for non-existence of the limit. So if you will read this chapter number 12.1, then you will get here like two-part test that is only for the non-existence of the limit. Okay, so this is one example. One more example here. So whenever you are getting this kind of situation, 0 by 0 form, so further investigation is required. So in that case, either what you have to do, you have to simplify your problem and then you have to plug your the value of x and y. Okay, one more example, similar kind of x square minus xy upon under root x minus under root y. X comma y is tending to 0, 0. Now do it.
Ma'am, can you please name the book which we have to follow?
I told in the previous class also, it is Thomas and Finney. Thomas and Finney. Online, it is available.
Thank you, ma'am.
Ma'am, is the answer 0?
I'm
Again,
0.
you are getting 0 by 0 form. You are getting 0 by 0 form. When you are getting, so whenever you are getting this 0 by 0 form, this is indeterminate form, then what we will do? We will try to-
Rationalize.
yeah. So we will take x common. So x minus y upon under root x minus under root y. So we will rationalize it. So the same procedure as we have discussed. And then we will try to find a limit.
मैम एल हॉस्पिटल हो सकते हैं ना इसके अंदर?
It is not allowing 2 dimension. Is not allowing in 2 dimension. Okay. So what is coming out to be x? So x minus y under root x plus under root y upon x minus y. Okay. That is getting cancelled. So what is coming out to be? Limit is coming out to be g. Understand? So whenever you are getting this kind of situation, then you have to simplify it. Okay. One more example I am taking here. I think then it will be more clear. Maybe some example is given in your.
So here as well, we can say the limit exists, or we can say it is only the test for non-existence.
Yeah, 2-part test is only for non-existence. Like I'm going to discuss one example. So this is the, just a minute. So these are the questions that you have to go, you have to do. That is 12.2 exercise, 12.2 from your book. So these are the question number 30, no limit at a point. So there's some example 35, no, question number 35. So if you say this is 30, just and
Ma'am, this is the 9th edition of Thomas and Finley, right?
limit, what is given here, x y is tending to 0, 0, and function is given here x upon under root x square plus y square. No. Okay, so in this case, you are not like, in this case, it is not possible to simplify it. So what we will do now, we will check, now we will apply y equal to mx. This is 2-part test. Yeah, also you're getting like 0 by 0 form, but it is not like, you cannot simplify it. So what you will do, you will just apply 2-part test. Okay. So now limit x comma y is tending to 0, 0, x upon under root x is tending to 0. So y equal to mx, x square plus m square x square. Understand? So limit x is tending to 0, x
The
upon,
limit does not exist, I think.
here we are getting 1 plus m square x. So here the limit is depending on m, 1 plus m square. Okay. So depending, so limit depend on m. So limit does not exist. Limit does not exist. Limit does not exist. I just want to like, who is your GR? Like अभी तक तो शायद कोई GR नहीं बना होगा. कोई भी आपकी क्लास में ना, like just form a WhatsApp group 859168662527. This is my phone number, and send me a message so that I can share lecture notes as well as video of these lectures. Okay, so this is my phone. Who is
I'm Bhavika.
GR is
Ma'am, GR is Mukesh.
I am CR, not GR.
Ma'am, GR for 22 is Persh, and for 23 it's Bhavika, and 24 it's Lakshay.
Okay,
When we
so
also have an official group, we can add you there and you can send the notes there directly.
Yes, ma'am.
that you can do, that you can do. Otherwise, just write the like जो भी आपके 3 sections है ना, उनका GR का different नेम, जो भी उनका नेम है और उनका रोल नंबर है और उनका मेल आईडी, वो मुझे मतलब ग्रुप वाइज सेंड कर दो, है ना. जो भी 3 GRs है ना, जो आपके 3 sections है ना मेरे पास में 19, 20, 21 आई थिंक, उनका like GR कांटेक्ट करें मुझे on this number. ठीक है. So these are the questions from 35 to 42. They are all based on 2-part test. So try it. You can take pick, or you can find out these questions from the book and the book name is Thomas Finney. So what we have discussed in this class today, we have discussed about the function of two variable and limit of the function of two variable, two-part test. Okay, and that is two-part test is basically for non-existence of the limit. So in this particular chapter, you will study only like how to show limit does not exist whenever x, y is tending to 0, 0, generally like 35 to 42 questions. But in the next class, we will discuss how to find out limit of the polynomial and other functions, etc. So one more lecture it will take, and then it will be okay. So do all these questions from 35 to 42. And then you can ask question through WhatsApp if you are facing any problem. Okay.
मैम आपको व्हाट्सएप नंबर दिखाना एक बार फिर से.
Yeah. 8591686627.
Thank you, ma'am.
Okay. And my name is Dr. Sapna Sharma. Okay, so let's finish our class here.
Okay, thank you, ma'am.
Okay.
Thank you, ma'am.